Good morning, students. So today we are going to discuss the topic electrochemistry. Okay, so we'll start with the topic electrochemistry. So what is electrochemistry? So electrochemistry is the study of chemical processes, right? So that involves or that causes the electrons to move. Okay, so it deals with the relationship of electricity. So electrochemistry is nothing but you involve the electricity. Okay, so it deals with the relation of electricity wherein your chemical changes occurs. Okay, and there can be interconversion between chemical changes to electrical energy, okay, or electrical energy to chemical energy. So there is interconversion of chemical energy into electrical energy. So this is about electrochemistry. So we are going to start with the topic. So we'll see certain terms. So the first term is electrolytes. Okay, what do you mean by electrolytes? So electrolytes are substances whose aqueous solutions, okay, can conduct electricity. So electrolytes are the substances wherein the aqueous solutions or fused states can conduct electricity. So these electrolytes, so when you dip in your electrode, okay, when you pass the electricity, so what happens? There will be positive and negative ions. So electrolytes are such substances which have some, which consist of ions. So when you pass electricity, they start conducting. So these are called as electrolytes. Next is electrolysis. What do you mean by electrolysis? When you supply electric current, okay, when you supply electric current, what happens? So there will be decomposition. Okay, there will be decomposition of an electrolyte when you pass electricity through a solution. So what happens? Chemical decomposition takes place. So when you pass electricity, all the ions of one particular type of ions get accumulated at one particular place. Okay, when you supply your electric current. So electrolysis, when you supply electric current, there will be chemical decomposition. Okay. So acid, bases, salts in water and fused salt, etc. are example of electrolytes. Okay. So acid, bases, salts in water and fused salt are examples of electrolytes. So electrolytes are nothing but they consist of different ions. Note, so solution of cane sugar. So cane sugar, so solution of cane sugar, glycerin, alcohol are examples of non-electrolytes. Non-electrolytes means what? So these solutions, they do not conduct electricity. Okay, when you pass electric current, it will not conduct any electricity. So these are certain examples of non-electrolytes. So what are the product of electrolysis? So product of electrolysis, it depends upon three factors mainly. The first is nature of electrolyte, second is concentration of electrolyte, and third is nature of electrodes used. So electrolysis, the product of electrolysis, it depends upon these three factors. The first is nature of electrolyte, second is concentration, and third is nature of electrodes used. So what do you mean by electrodes now? So electrodes which do not take part in chemical change, okay, which is involved in a cell, are known as inert electrode. What do you mean by inert electrode? So there will be no, the electrodes. So these are the electrodes which do not take part in chemical change. Okay, so they act inert. Okay, inert means no reactivity takes place with respect to these electrodes. Okay, so these electrodes, they do not take part in chemical change which is involved in the cell. So thus they are called as inert electrodes. So there are two examples, graphite and platinum. So mainly when you are doing, when you are studying about the cells, okay, so the electrodes which are used will be platinum. So platinum electrode is used because this is an inert electrodes. So these electrode, when it is used in any chemical cell, okay, so they do not participate in the chemical change. Next is electrodes which take part in chemical change. So when some electrodes which take part in chemical change, which is involved in a cell, then they are called as active electrode. Okay, so so these electrodes which will take part in a chemical change, so these are involved in the cell reaction, then They are called as active electrodes. So the example is graphite and mercury. Okay, Hg. So then we'll see the Faraday's law of electrolysis. Okay, we'll come to the Faraday's law of electrolysis. So Faraday's, he gave his two laws. Okay, the first law. So first, for Faraday's first law, what it states that the mass of any substance. Okay, the mass of any substance which is deposited or liberated. So the mass of any substance which is deposited or liberated at any electrode is directly proportional to the quantity of electricity passed. Okay. So this is the statement given by Faraday. So what is Faraday's law? So mass. So whatever. So when you supply a quantity of electric current. Okay. So the mass of any substance which is deposited. So whenever you supply a quantity of electric currents, so that depends upon the mass of any substance which is liberated or deposited at any electrode. So the how much of amount of mass is produced, it is directly proportional to the quantity of electric supplied. So how much amount of electric supply electricity you are supplying, that much amount of mass is being deposited. So Faraday's law is stated like this. So how it is given in mathematical form is W is directly proportional to Q. Okay, where W is your mass of ion which is liberated in grams. So W is the mass of ion which is liberated in grams. Q is a quantity of electricity passed in coulombs. Okay, Q is the quantity of electricity passed in coulombs. So Q, this Q, it stands for electricity, quantity of electricity passed. So this Q, it is given as current in amperes into time in second. That is I into T. Okay. So Q is equals to I into T. So Q, I is what? I, it represents capital I, it represents your current in amperes, and time small t represents your time in seconds. So this is about Faraday's first law. What is Faraday's first law? The mass of any substance which is deposited or liberated at any electrode is directly proportional to the quantity of electricity passed. So it is represented as W is directly proportional to Q. Okay. So this is the first Faraday's law. So W is directly proportional to Q. Okay. So what is Q? So Q is your I into T. So it is, so we have substituted. Just a second. Okay. So we have substituted here. So we have substituted your Q, right? W is directly proportional to Q. Q is nothing but your I into T. Okay. So when you remove this proportionality sign, so you are introducing a constant, that is Z. So Z is nothing but your electrochemical equivalence. It is called as electrochemical equivalence. Okay. So electrochemical equivalence. So W is equals to, when you remove this proportionality sign, you are introducing a constant, that is Z, that is electroequivalence, chemical equivalence. So if I is equals to 1 ampere, okay, if you substitute I is equals to 1 ampere and T is equals to, that is your time is equals to 1 second, then W is given, W is equals to Z. Okay, W is equals to Z. So how do you define the electrochemical equivalence? How do you define the electrochemical equivalence? So electrochemical equivalence of a substance is the mass of the substance which is deposited when a current of 1A, that is 1 ampere, is passed for 1 second. So this is the statement or the definition for electrochemical equivalence. So how do you get the definition? So if you substitute I is equals to 1A and time is equals to 1 second. Okay, then you get W is equals to Z. So electrochemical equivalence is the amount of substance which is deposited when a current of 1 ampere is passed for 1 second. So this is the definition of electrochemical equivalence. So for 1 Faraday. So what is the value of 1 Faraday? So 1 Faraday is 96,500 coulombs. Okay, 1 Faraday is 96,500 coulombs. That is the charge which is carried by 1 mole of electrons. So this is the charge. So 1 Faraday, which is 96,500, it is a charge which is carried by 1 mole of electrons. So how do you define the electrochemical equivalence? Therefore, electrochemical equivalence is equals to equivalent weight of the element divided by 96,500. So thus you define your electrochemical equivalence as equivalent weight of the element upon 96,500. 96,500 is nothing but your Faraday. It is a value of 1 Faraday. So next is your Faraday's second law. Okay, what is Faraday's second law? It states that when the same quantity of electricity, okay, when you supply the same quantity of electricity which is passed to different electrolytes, okay, when you pass same quantity, so when you're passing same quantity of electricity through different electrolytes, the masses of different ions which are liberated at different electrodes are directly proportional to their equivalent weights. Okay, so here the statements goes like this. So the statements, it goes like this, that is when the mass, when the same quantity of electricity is passed to the different electrolytes, okay, the masses of different ions which is liberated at the electrodes are directly proportional to their equivalent weights. Okay, so this is second law. So W1, so you know what is W1? So W1, it represents your mass, and E represents the equivalent weight. So whatever the amount of electricity you're passing through different electrolytes, so masses which is of different ions is directly proportional to their equivalent weights. So equivalent weight, so if they're different electrolytes, so different electrolytes mean different equivalent weights are there, right? So you represent different masses with W1 and W2, and with their respective equivalence weight as E1 and E2. So W1 is directly proportional to E1, W2 is directly proportional to E2. Therefore, W1 divided by W2 is equals to E1 by E2. Okay, this is your Faraday's second law. So we'll solve some questions. So when during electrolysis of a solution of AgNO3, okay, that is silver nitrate. So when you are doing a electrolysis of solution of AgNO3, 9,650 coulombs of charge pass through the electroplating bath. Okay, the mass of silver which is deposited on the cathode will be. So this is what it is depending upon your first law. So here you have to relate. Okay, you have to relate. So try to solve this and answer. Yes. Yes. Yes, it is B. Okay, it is B. Most of you have answered it right. B. So we'll solve this. Okay, we'll solve this. Who have not understood why it is B, so we'll solve for them. So you know that this is a reduction reactions. Okay, so when during electrolysis of a solution of AgNO3, so how it undergoes the reaction goes like this: Ag plus electron, okay, giving you Ag. Okay, this is what reduction. Reduction is what? Gain of electrons, right? So if 1 Faraday of charge, okay, 1 Faraday of charge is required to deposit 1 mole of Ag. Okay, how much? That is 1 mole of Ag. 1 mole of Ag. That is how much? 1 mole is equals to 96,500 coulombs of charge is required, right? So this much amount of charge is required to deposit how much? What is the mass of AgNO3? It is 108 grams of Ag. Okay, this is a statement. So mass of Ag. So how much we required for mass of Ag? Okay, which is deposited. So you have to deposited with 9650 C. Okay, so this is for one. Okay, we have to see for 9650 coulombs. So when you supply this much amount of electric current, so how much amount of Ag is deposited? So how it will be? So 108, okay, 108 into 1, okay, divided by, so 108 into 1, so into 1, okay, then divided by 96,500 into 9,650. You have to do cross multiplication, okay, you get 10.8 grams. So the answer is 10.8 gram. I hope you understood this. So it is just, yes, so it is, yes, most of you have answered it right. It is B. Okay, so this is the, so this is the answer. This is a way you're going to answer the question. I hope you have understood it. Okay, so this is according to the first law. So we'll go for the next question. So electrolysis of dilute aqueous NaCl solution was carried out by passing 10 MA current. Okay. So the time required to liberate 0.01 mole of H2 gas at cathode is, so 1 Faraday is given as 96,500 coulombs per mole. Okay. So what is the answer? So electrolysis of dilute aqueous NaCl solution was carried out by passing 10 milliampere current. The time required to liberate 0.01 mole of H2 gas at cathode is. So we have to use this formula. Okay, that is W. So you know Q is equals to IT, right? So we have to use this particular formula. That is Q is equals to IT. Yes, Damini. Abhishek, yes, the answer is B. So how it is B? How it is B? So we'll solve this. We'll solve this for the others who have not understood it. How it is B? Okay. So you know Q is equals to IT, right? Q is equals to IT according to first law, right? We have seen this, how it comes Q is equals to IT. So in the electrolysis of dilute NaCl solution, okay, water will be participating, right? Dilute aqueous means what? Water is participating here, right? So water, it associated with H2O, okay, plus 2 electrons, giving you H2 plus 2 OH minus, okay. So so how much, what is asked here? So electrolysis of dilute aqueous NaCl, aqueous means water is associated, was carried out using passing the 10 milliampere current. The time required to liberate 0.01 mole, okay, of H2. So here how much mole? So you have to see. So here how many moles of electric current is used? So 2 mole. So 2 more. So generally, this is general, in general, okay, in general. So that is for 2 moles, how much it is used? 1 mole is used, right? 1 mole is used. Then we have to see for how much? 0.01 mole of H2. Okay, 0.02 mole of electron, right? That is 0.02 Faradays are consumed, right? If you see this general equation, for one mole, 2 moles of current is charge is used. So for 0.01 mole of H2, 0.02 mole of electrons or current charge is used, right? So charge required So charge which is required, that is Q, okay, is given as what? 0.02 into you have to multiply it with Faraday. So that is 96,500. Okay. So current is what? Your current is what? This is your charge. So this is your charge. Charge you represent as what? 0.02 into your Faraday's constant. Now current is what? Current given pass is 10 milliampere. Okay, so 10, okay, 10 into 10, 10 into 10 raised to minus 3. If you, okay, so time. So what they have asked, Q is equals to IT. So we know now, we know Q, we know I. Okay, we don't know T. So T is equals to Q by I. So what is Q? Q is 0.02 into 10, 96,500 divided by 10, 10 into 10 raised to minus 3. Or you can represent this as 0.01. Okay, you can represent this as 0.01. You can write this as 0.01. Okay. So after solving, you get what answer? It is 19.3 into 10 raised to 4 seconds. Okay. I hope you have understood it. Okay, so this is the way you're going to solve. So electrolysis of dilute aqueous NaCl was carried out by passing 10 milliampere current. The time required to liberate this gas is. So you have to calculate so you have to relate it first with general equation. Then you have to, for 0.01, how much time is required, you have to see. Okay, so just cross multiply and you get your answer. Okay, so this is the way you're going to solve this particular question. So next, when a quantity of electricity is passed through copper sulfate solution, 0.16 gram of copper gets deposited. If the same quantity of electricity is passed through acidulated water, then the volume of H2 liberated at STP will be. So given atomic weight of copper is 64. Okay. So here, so this is based on what? This is based on second Faraday's law, right? So because two electrolytic solutions are used. First, it is used passed to copper sulfate solution, and then it is passed to acidulated water. So what will be the answer? What will be the answer? Yes, what will be the answer? Tila- ఇంకా Yes, what will be the answer? How we will solve it? This is based on second law. Okay, this is based on second law. So you have to see first what is mass. Okay, how it is given? W1 upon W2 is equals to E1 upon E2, right? So mass of copper divided by mass of H2, right? First it has been what? It has been passed to copper sulfate solution, then acidulated water. So mass of copper upon mass of H2 equals to equivalent mass of copper upon equivalent mass of hydrogen, right? Yes. After this, what is mass of copper given as 0.16, right? 0.16. So we don't know what is the mass of H2, right? So keep it as it is, mass of H2. Then what is equivalent mass of copper? Equivalent mass of copper is what? 64, right? 64, you have to divide it by 2 because equivalent weight, you are going to do equivalent weight. So whenever equivalent weight is given, you have to divide it by its charge. It is plus 2 charge. So divided by its charge 2. Then equivalent mass of hydrogen is 1, right? It is 1. Then, so you have to just cross multiply. So mass of H2 equals to, so after solving this, you get 0.16 divided by, this is what? 32. So you get after solving okay. So after solving, you get this as 0.5 into 10 raised to minus 2 grams. Okay, that you can write as 5 into 10 raised to minus 3 grams. Okay. Okay. So now for 2 grams, if the same quantity okay, of copper is deposited, passed to acidulated water, then the volume of H2 liberated at STP will be. So now for 2 grams of H2, okay, is equal to 22,700 centi-cube at HCP. Okay, at HTP. So you have to see the volume of H2 liberated at HTP. Okay, so STP standard temperature pressure, the it is given as 22,700 centimeter cube. Okay, so for 2 grams of H2, it is equal to 22,700 centimeter cube at HTP. So for 5 into 10 raised to minus 3 grams, how much? Okay, you have to find the estimate condition. So what you have to do? So therefore, 22,700 divided by 2 into 5 into 10 raised to minus 3. Okay, after solving this, you get 56.75 centimeter cube. So the answer is B. Yes, most of you have answered it. What? Yes, B. Yes, B is the answer. Okay, Damini Shilpa. Yes, it is B. B is the answer. So this is the way you are going to solve. So at STP conditions, so first we have found out. Okay, then we have determining it according to the STP conditions. STP conditions, you have to see STP condition for 2 grams of H2 is equal to 22,700 at HTP. Therefore, 22,700 divided by just cross multiply into divided by 2 into 5 into 10 raised to minus 3. It comes to 56.75. Okay, so the answer is B. So the answer is B. Next question. In the electrolysis of acidulated water, it is desired to obtain 1.12 cc of hydrogen per second under STP condition. The current to be passed is. So this is also based on your first. So you have to find out the current. Okay. So moles of H2 produced. So first you have to see moles of moles of H2 produced. So how much moles? How do you calculate? 1.12. Okay. Divided by your 22,400. So you have to. So in the electrolysis acidulated water, it is desired to obtain 1.12 cc of hydrogen per second at STP condition. So whenever STP condition is there, you have to multiply it by or you have to divide it by 22,400. That is your standard temperature pressure conditions. Okay. So so mass of H2 produced. So mass of H2 produced. So we have to see how much mass of H2 is produced. That is W is equals to 1.12 into 2. Okay, 1.12 into 2 divided by 22,400. So this answer you get is 10 raised to minus 4 grams. So you know the formula, W is equals to ZIT, right? So this can be again rewritten as what? E, right? E into I into T divided by 96,500. Okay. So because it is at HTP conditions. So what is the equivalent weight? It is given as 1 gram. 1 gram into what is the weight? Weight is 10 raised to minus 4. Okay, 4 gram, 1. Then what is time? Time condition will be 1. Okay, 1 because at standard temperature pressure. Okay, what is I? We don't know what is current. So keep current as it is. That is I divided by 96,500. Okay. So after solving this, you get it as 10 raised to minus 4 into 96,500. This divide, if you could take this side, it becomes multiply. So it becomes 9.65 Armstrong. Okay. The answer is B. The answer is a B. Understood? So you have to just see. So this is all according to standard temperature pressure. Yes. Okay. So next concept is of resistance. Okay, what is resistance? So the resistance of any conductor is directly proportional to the length. Length is represented as small l, and it is inversely proportional to the area of cross section A. Okay, so the resistance is of any conductor. It is directly proportional to the length L. So how it is represented? So you can see here, and it is inversely proportional to the area of cross section that is given as small a. So R represents your resistivity. So resistivity is directly proportional to L. Okay, it is directly proportional to L, and it is inversely proportional to the cross section area, that is A. So when you remove this proportionality sign, okay, when you remove this proportionality sign, you introduce a constant rho. So this is your rho. So that is R is equals to rho into L by A. Okay, where rho, this rho, it is called as specific resistance or resistivity. So it is called as specific resistance or resistivity. So what is the resistance? Unit of resistance, it is ohm. Ohm. Okay, it is represented as this ohm. So remember what is the definition, what is the mathematical representation, and what is the unit. So this is important. What is the unit of resistance? Okay, what is the definition and its mathematical representation. Next is resistivity. Resistivity rho. Okay, we know that. So we know that resistivity R is equals to rho into LA. So when you remove the proportionality constant, you introduce rho. Okay, so if length is equals to 1 centimeter and area of cross section is 1 centimeter square, then what your rho is directly is equal to resistivity. Okay, so rho is equals to R into A by L. So unit of rho. So what is the unit of rho? Rho is ohm meter or ohm centimeter. So this is the unit of resistivity. So remember the unit of resistivity is important. So it is represented as ohm meter or ohm centimeter. So this is the unit of resistivity. So what is next is conductance. Conductance is denoted by G. Okay, conductance is denoted by G. So the conductance of any conductor is directly proportional to the area of cross section A and inversely proportional to the length. So it is inverse. It is inverse of resistance, right? It is inverse of resistance. In resistance, it is directly proportional to length, and it is inversely proportional to cross section area A. So this is inverse of resistivity. So you can see here the conductance is directly proportional to area of cross section A and inversely proportional to length. So how it is given? G is directly proportional to A and inversely proportional to L. So it is given. So you are removing this proportionality sign, and you are involving, you are introducing a constant K, and this constant K, it is called as conductivity. It is called as conductivity. What is the unit of conductance? It is ohm per okay, per ohm. It is per ohm. It is per ohm, or it is represented as Siemens. It is represented as Siemens. Remember the units. units is important. So your resistance is inversely proportional to your conductance, right? So it is inversely proportional to conductance. So your the unit of conductance is per ohm, or it is represented by Siemens. Conductivity, what is the definition of conductivity? So it is the reciprocal of resistivity. So as I have said, it is a reciprocal of resistivity, or it is the conductance of 1 centimeter cube of an electrolyte. So how it is represented? K. Okay, small k is is your conductivity. So it is given as L into A into G is your conductance. So the unit of conductivity is Siemens per centimeter or Siemens per meter. So remember the conductivity units. Okay, units are very important. So units are very important. So what is the conductivity unit? It is Siemens per centimeter or Siemens per meter. So this is the units of conductivity. Next is cell constant. So cell constant. So for any particular cell, so length upon area of cross section is constant. Okay, for any particular cell, length upon your area of cross section is constant, and this is called as cell constant. So conductivity is given as, that is K is given as conductance into cell constant. So conductivity is conductance you represent as G, and cell constant is represented by G star. So resistivity, you know, resistivity is nothing but resistance upon cell constant. So rho. So rho is given as what? Rho is inversely 1 upon K, that is inverse of conductivity. Okay, yeah. So rho, you know, it is inverse of conductivity, that is represented as R, that is resistant upon the cell constant. So therefore, cell constant is equals to resistivity into conductivity. So this is the cell constant. So cell constant for any particular cell, that is L by A, it is constant and it is called as cell constant. So these are some of the definitions which are involved in your electrochemistry. So next is molar conductivity. What do you mean by molar conductivity? It is represented by this. Okay, it is represented. So the definition, it is the conductance of all the ions which is produced by ionization of 1 gram mole of an electrolyte. So it is the conductance of all the ions which is produced by ionization of 1 gram mole of an electrolyte. So the formula, it is given as lambda m, okay, is equals to K, small k into 1000 divided by capital Q. So unit of K is Siemens per centimeter. K is what? It is your conductivity. Unit of C is mole per liter. Okay, and unit of delta, this lambda m is Siemens per centimeter per mole. So these are certain units. Okay, so these are units. So this is molar conductivity. So the conductance of all the ions which is produced by ionization of 1 gram mole of an electrolyte. So this is nothing but your molar conductivity. So next, the second formula which can be represented as delta lambda m is equals to K by 1000 into C. Okay, so these are so this is the second formula which can represent your molar conductivity. Next is Kohlrausch's law. Okay, next is Kohlrausch's law, very important law. So Kohlrausch's law, it states as the molar conductance of an electrolyte at infinite dilution is sum of the molar conductance of cations and anions. So this is very important. Kohlrausch's law is important. So what it states that the molar conductance of any electrolyte, at infinite dilution is sum of the molar conductance of cations and anions. Okay, so this is the representation. Okay, it is a mathematical representation. So that is a sum. So it is a molar conductance. So that is molar conductance is equals to sum of molar conductance of cations and sum of molar conductance of anions. So these are your ionic conductances of cations and anion at infinite dilution respectively, and x and y, this small x and y, it represents your number of cations and anions in one formula unit of an electrolyte. So this is the Kohlrausch's law. So next is degree of dissociation. Degree of dissociation is represented by alpha. Okay, represented by alpha. So it is molar conductance at a given concentration divided by molar conductance at infinite dilution. Okay, so this is the representation of degree of dissociation. So at molar conductance at a given concentration upon molar conductance at infinite dilution. So we'll solve some questions based on molar conductivity. So the molar conductance, limiting molar conductivities of lambda naught for NaCl, KBr, and KCl are 126, 152, and 150 Siemens per centimeter per mole respectively. So the lambda naught for NaBr is, yes, how will you solve this? So we have to find the lambda naught, okay, for NaBr. Okay. So it is a sum of all the cations, molar conductance of cations and anions. So first lambda into NaCl plus lambda naught into KBr, okay, minus lambda naught into KCl, right? So after write the values, NaCl is what? 126 plus KBr is 152 minus this is 150. So it comes to what? What is the answer? Yes, the answer is A, right? The answer is A. So NaBr, how do you obtain NaBr? NaCl plus KBr, right? NaBr and KCl is added, right? So here minus you are doing your KCl here, right? It is a minus KCl. So like this, after substituting the limiting molar conductances, you get the answer 128 Siemens per centimeter per mole. So this is the answer, right? So this is a way you're going to solve the question. So next, electrolyte KCl, KNO3, HCl, NaOAC, NaCl, and its lambda naught values are given. So you have to calculate for lambda naught of HOAC using appropriate molar conductance of the electrolyte listed above at the infinite dilution in H2O. Okay. So we have to find for lambda naught for what? Lambda naught for, okay, ACOH. So how you will find it? So it is lambda naught of NaCl, sorry, lambda naught of this, okay, sodium acetate, sodium acetate. How do you get acetic acid? Sodium acetate plus lambda naught of HCl, okay, minus lambda naught of NaCl. Yes, substituted. This is 91 plus HCl is 426.2 minus what is NaCl? It is 126.5. So for ACOH, you get what? What is the answer? Yes, it is 390.7, right? The answer is 390.7 Siemens per centimeter per mole. Okay. So for acetic acid, it will be the answer. The one which decreases with dilution is the one which decreases with dilution is. So you have seen the definitions of molar conductivity, conductance, conductivity, equivalence, conductance, how it is related, and what happens when dilution. So with the dilution, what happens? Which decreases with dilutions? Yes. Yes. So which one of the following will decrease with the dilution? Yes, it is C. Okay, it is C. So conductivity. Okay, conductivity. What happens to conductivity? So conductivity decreases with dilution because number of ions per unit volume decreases with dilution. That is number of ions. Okay, number of ions per unit volume decreases with dilution. Right. So because of this factor, conductivity decreases. Whereas your molar conductivity, okay, equivalent conductance, okay, and conductance, what happens? They increase with dilution. Why? Because degree of ionization will increases. So when you're talking about conductivity, molar conductivity and equivalence conductance, what happens? So there will be increase in dilution. Okay, there will be increase in dilution. What is the reason? Increases. So they increase with dilution. So they increase with dilution. Okay, as degree of ionization increases. Okay, remember this. Remember this. So what happens? So conductivity decreases because number of ions per unit volume decreases with dilution. And what other factors, that is molar conductivity, conductance, equivalent conductance, they increase with dilution as degree of ionization will increase. Okay. So this is the reason. Degree of ionization is independent of. So what about degree of ionization? What it is? It is independent of what factor? Yes, degree of ionization is independent. It is not dependent on which factor. It is independent. That factor is independent of degree of ionization. Yes, D. Rakshita, yes, it is a D. Pressure. Okay, it is pressure. How? So degree of ionization, increases with dilution. Right, degree of ionization increases with dilution, increases in temperature, and decreases in the presence of common ions. Okay, so it is independent of pressure. It is independent of pressure. So degree of ionization is independent of pressure. Okay, so this is the answer. So we'll go for the next one. The molar conductivities of NaOH, NaCl, and BaCl2. Okay. At infinite dilutions are 2.481 into 10 raised to minus 2 cement per meter per mole, 1.265 into 10 raised to minus 2 cement per meter per mole, and 2.800 into 10 raised to minus 2 cement per meter per mole, respectively. The molar conductivity of barium hydroxide at infinite dilution will be. So same molar conductivity problem. How we'll solve this? Yes. So you have to find it for molar conductivity of sodium, barium hydroxide. So you have to solve it for barium hydroxide. So how will obtain barium hydroxide? Barium chloride, okay, plus barium chloride plus NaOH. So you have to add two hydroxides. So it will be 2 times NaOH. Okay. Then so it becomes, okay, then you have to subtract what? 2 times NaCl. Yes, substitute this and you will get the answer. So substitute the values. The values are given above. Just substitute and tell me the answer. Yes, what is the answer? Yes, the answer is A. Okay, after substituting, you will get 5.232. So the values are given above. Just write, okay, and you will get the answer this. I hope you have understood it. Okay, we'll go for the next one. We have solved this type. So the next one. So next is potential or EMF of the cell. Okay, electromotive force of cell. So EMF is given as reduction potential of cathode minus reduction potential of anode. That is, E cell is given as E cathode minus E anode. In a cell diagram, by a conventional, cathode is always written on right side and anode is written on the left side. So whenever you are representing your cell, okay, whenever you are representing your cell, so in the conventional method, your cathode will be always written as on the right hand side, okay, and anode will be on the left hand side. So E cell is equals to E right minus E left. So by convention, all the electrode potential are expressed as reduction potential. So next is Nernst equation. So as we have discussed here, that all the electrode potentials are expressed in terms of electrode potential. So your for a reduction reaction, okay, for any reduction reaction, it is represented as okay, M N T aqueous plus Ne. Okay, reduction means was gain of electrons, giving you M, that is in solid state. So according to Nernst equation, E is equals to E naught minus RT NF divided by NF ln of 1 by M NT. That is, this is concentration. Okay, this is concentration. So this represents your concentration of N M N T. So further, it is given as Nernst equation, E is equals to E naught minus 2.303. Okay, RT divided by NF log of 1 by concentration of M N T. Okay, so where N, this N represents your electrons which are involved in the reaction. So N represents your electrons involved in the reaction. E is your electrode potential. E naught is your standard reduction potential, and F is your Faraday's constant. Okay, so R, so when at R is equals to 8.314 joule per Kelvin per mole, and temperature is 298 Kelvin, and Faraday is given as 96,500 coulombs. Okay, then E is equals to E naught minus 0.0591 divided by N log of, okay, log of 1 by concentration of Mn plus. So this is at standard temperature. Okay, so this is Nernst equation. So remember these two equations, very important. So based on this, you will be solving some questions. So next is Nernst equation for a cell EMF. For a cell in which the net cell reaction involving and electrons, so the A, small a, capital A plus B into B gives you small d, capital D plus C, okay, capital C. Nernst equation is given as, so this is a chemical reaction. If there is a cell is undergoing a chemical reaction, so Nernst equation is written for this cell is E cell is equals to E naught cell minus 0.0591 divided by N log of, so it will be concentration of your products divided by reactant. So that is, this is the stoichiometric ratios. Okay, this tells you about the stoichiometric ratio. Okay, then this is your concentration. These are your concentrations. So this is the Nernst equation, okay, for any cell which is undergoing a cell reaction. So relation between a cell potential, Gibbs energy and equilibrium constant. So W max is equals to NAFE cell. So this is a first. So according to, so this is a first. Since decrease in free energy is equal to the maximum work that can be obtained from the cell. So Gibbs energy is given as, therefore negative Gibbs energy is equals to W max, that is work energy will be maximum. So when your energy, that is Gibbs energy, that is free energy, if there is decrease in the free energy or Gibbs energy, then it is equal to the maximum work. Okay, so from 1 and 2, okay, from if you relate the equation 1 and 2, then delta G, okay, that is Gibbs energy is equals to minus NFE cell. Okay, so in standard conditions, that is delta G naught is equals to minus NFE naught cell. So this is at standard condition. So remember this Gibbs energy. This is also important formula. So at equilibrium, when E is equals to 0, so if you substitute E is equals to 0, then E naught. Okay, then E naught cell, E naught of cell is equals to 0.0591 divided by N log of Kc. Also, delta G naught is equals to minus 2.303 RT log of Kc. So these are after solving, okay, after solving at certain standard conditions. So these are the equations we get. So based on this, we'll solve some questions for a cell given below. So that is Ag. Okay, Ag bar, Ag plus. So this is this represents your salt bridge. Okay, that is double lines. Then copper plus 2 slash copper. Okay, so these are your electrodes. So Ag dipped in Ag plus. Okay, then copper plus 2 solution with copper rod dipped in copper plus 2. So this is the okay, these are the values. So what E naught? So you have to find what is the E naught of this. Okay, what is the E naught of this? Yes, solve this. So E naught, how E naught is given? E naught of cell is given as E cathode minus E anode, right? E cathode minus E naught of anode, right? So what is E cathode? E cathode represents your right side. Okay, E naught cell is equals to what? E cathode, that is right side minus E of left side. So what is E cathode? E cathode is Cu plus 2. So what it is given as Y. So the E naught value is Y minus what is Ag? That value it is given as X. So Y minus X. So Y minus X is C. Yes. So C is the answer. I hope you have understood. So how do you calculate E naught of the cell? E naught of the cell is calculated by E naught of cathode minus E naught of anode. Okay. So this is the way you're going to calculate the E naught. So here they have given in general. If there are some values, so you have to just substitute the values and get the answer. Okay. So for the redox reaction, so this is a reaction taking place in a cell. E naught is 1.0 E naught is 1.10 volt. E cell for the will be for what will be the E cell for this given cell. So given 2.303 into RT divided by F is equals to 0.0591. So this is a standard. So this is a standard condition. So what will be the value? Okay. So you know the formula E cell is equals to what? E naught cell, okay, minus 0.0591 divided by N. So log of what? Log of your products. Okay, product is what? Zn plus 2 divided by your this is copper plus 2. Right, this is copper plus 2. Right, so this is your you're going to solve this. So right, what is E naught cell? E naught cell is given as 1.10 minus 0.0591, okay, divided by N. What is N here? Okay, N is number of electrons which are involved. It is 2, right? 2 electrons, so 2. Then what is log? Log of Zn plus 2 is Zn plus 2 is 1 divided by what is copper plus 2 is 0.1. Yes, 1.10 minus 0.0591 divided by 2. So log of 1 by 0.1, it comes to log of 10. Okay, so 1.10 minus after solving this, you get log of so solve this log of 10, then you get 0.0295. So after solving this, what you will get? What is the answer? It comes to 1.07 volts. Okay, so the answer is C. So the answer is C. So like this, you're going to solve the Nernst equation. So this is according to Nernst equation. I hope you have understood it. So it is a easy. Everything is given. The data is given. Just you have to remember the formula. Your formula is very important, and add the given quantities or entities in this, and you will get the answer. Okay. So solve it properly, stepwise, then you will get the answer. One more, the E naught, that is standard reduction potential of 3 electrons, that is A, B, and C, are respectively, okay, are respectively plus 0.5 volts, minus 3.0 volts, and minus 1.2 volts respectively. The reducing powers of these metals are. So what, remember this statement, that is lower, okay, lower the value of reduction potential. Okay, lower the value of reduction potential, more is the reducing power. Okay, more is the reducing power. So tell me now, so which is the lower value? So you have to tell. So more the reducing powers. So this statement you remember and see the values and you write the reducing power of the metals. Tell me the this reducing power, which is lowest, from lowest to highest. You have to tell me from lowest to highest. Which comes first? So lower the value. Now, which is the lower value here? 3. Right. Then comes your 1.2 minus 1.2. 0.2, then comes your 0.5. So the answer is C. Okay, the answer is C. So the lower the value of reduction potential, more is the reducing power. So lower the value, more is the reducing power. So this is the answer. Okay. I hope you have understood. So we'll just a second. I have one more question. So we'll solve this one last EMF. The standard electrode potential for the half cell reactions are. So these are the so EMF of the cell reaction is. So you know E cell how it is given. E naught of cell is equals to E cathode minus E anode. E naught of anode. Yes, what is E cathode? What is on the positive side? So the cell representation is what? Zn linked in Zn plus 2 divided. This is Fe plus 2 dipped in Fe. Okay, so this is anode. This is cathode. Yes, what is answer? Yes, the answer is D. Okay, so E cathode, what is the value? E cathode value is minus 0.44 minus of minus 0.76 volts. So this comes to be plus 0.32 volts. Okay, so this is the way you're going to solve it. Okay, this is the way you're going to solve it. One more, the for a cell reaction involving two electrons chain, the standard EMF of the cell is found to be 0.295 volts at 258 Kelvin. The equilibrium constant of the reaction at the same temperature will be. Okay, so here E naught, they've asked what E naught of cell is equals to 0.0591 divided by N into log of K. So equilibrium constant. Okay, we have to find the equilibrium constant of a reaction at the same temperature. Okay, so E naught of cell is given as what? 0.295. Okay, so that is equals to 0.095 N. For a cell reaction, the standard EMF of the cell, the equilibrium constant. So how many electron change is there? 2 electron change. Okay, so 2 electron, then log of K. So we have to find the equilibrium constant here. Okay, equilibrium constant. So after solving this, okay, you get, so this will be, it comes to 10. So it will be log of K is equals to 10. So this, it will go and multiply here. This will come and divide. So you'll get what? Log of 10. Okay, you get log of 10. Okay, so K is equals to what you have to do? You have to take the anti-log of 10. So that comes to 1 into 10 raised to 10. Okay, the answer is C. Yes, the answer is C. Okay, the answer is C. Understood? Okay, so here they have asked the equilibrium constant. Okay, they have asked the equilibrium constant. So by solving, by taking this particular formula, you have to solve this. Okay, I hope you have understood today's session. Okay, so this completes your electrochemistry. So we'll meet in the next class with a new chapter. Thank you. Have a nice day.
Thank you, ma'am. Thank you, ma'am.
ಮ್ಯಾಮ್ ಹೋದ್ರು.